Joining us now is the 2019 MRS Von Hippel Award winner. My pleasure to introduce to you Dr. Jerry Tersoff. Dr. Tersoff, thanks for spending some time with us. And congratulations, by the way. Your citation reads, "For advancing the understanding of low-dimensional and nanoscale electronic materials, surfaces, and interfaces through elegant theoretical models that highlight the essential physics controlling growth, structure, and electronic properties." I want you to tell us a little bit about your work and how you came to be interested in that particular field.
So, as you might guess from this citation, it's really not just one field. So in my career, I've worked in a number of kind of different areas, and that was written to try to cover those. So I think if there's a unifying thread through all my work, it's basically that there are a lot of problems that come up that are too complicated to really solve properly. And so I try to make simple models that let you at least get some insight into the problem. That's always how I thought of physics as being, because that's how it is in textbooks. But it's been wonderful for me that I've been able to make a career doing that sort of thing.
Sure. What are some applications or devices that have resulted from the work in your field?
It's been sort of the other way around. There will be an application that makes people work on some materials set, and then that throws up problems, and then those problems interest me. So for example, the first thing I worked on was Schottky barriers, which are a classic problem for a lot of electronic devices. You have a metal in a semiconductor, and the interface has an electronic barrier. There was a lot of phenomenology understood, but not a unifying idea. And I started out trying to do a real calculation and found out it was just too hard. So I started thinking, well, you know, what's a simple picture that explains it? And I was actually able to come up with an idea to capture sort of the essence of why you always have this barrier. And it's very simplistic, but I think it's been very useful because it changed how people think about the problem.
And that's interesting and fantastic. By the way, your award talk is titled Simple Models for Complex Behavior and Nanowire Growth. What are some of the key points from your talk there?
People have studied nanowires for quite a while now because they have a lot of potential applications. And for most of those applications, you want wires that just grow simply straight up from the surface. And that's been pretty well understood for quite a while. But often people see more complicated behavior, and nobody had a way of modeling that more complicated behavior because it's not feasible to do a really realistic calculation. So my collaborators and I were able to come up with a very simple model that you could play around with it on the computer. I like to play around.
Right.
But still it could capture a lot of the complexity of these real systems. And one of the highlights was that we were able to actually predict some complex growth modes and then see them in experiment.
Ah, okay. Now you've been a long-standing member with MRS. How has engaging with MRS been a positive factor in your career?
Like a lot of scientists, you know, if left to myself, I'll just work on my science, and I kind of ignore all the administrative stuff.
Right.
But being on the board of MRS, you're forced to engage with both the strategic issues of an organization and the people issues, and also just what it takes day to day to keep things running. And you meet some remarkable people, because on the board there were some people like me with very little experience in that sort of thing, but there were other people with tremendous experience and knowledge that I was able to learn a lot from. So that was a wonderful experience.
Dr. Jerry Tersoff, again, congratulations, 2019 MRS Von Hippel Award winner. Great speaking with you.
Thank you.